Can India field a true fifth-generation fighter before China deploys 1,500 stealth jets? That question now defines the future of the Indian Advanced Multirole Combat Aircraft program, a project delayed again with its first prototype flight pushed beyond its original 2028-2029 target. This video examines what those delays mean, how they reshape India's air power strategy, and why the answer could alter the military balance across Asia without yet revealing whether the program ultimately succeeds or stalls. If the AMCA slips further, India's ability to maintain parity with China's rapidly expanding stealth fleet could weaken through the 2030s. If it succeeds, New Delhi could secure long-term aerospace autonomy and reduce reliance on foreign suppliers. At stake is not only one aircraft, but India's position in a regional competition increasingly defined by advanced sensors, low observability, networked warfare, and industrial capacity. The AMCA concept emerged in the mid-2010s as India assessed the implications of China inducting the J-20 stealth fighter into service. The Defense Research and Development Organization began formal program development nearly a decade ago, and Hindustan Aeronautics Limited entered detailed design in February 2019. Initial timelines envisioned a first flight around 2028 or 2029 and operational service by 2033 or 2034. As of 2026, operationalization has shifted to 2034 or 2035 with no public display of a flying prototype or major subsystem. In May 2025, Defense Minister Rajnath Singh approved continued progress on the program, describing it as a catalyst for indigenous capability and aerospace ecosystem growth. The ambition is substantial. The Mk1 variant is expected to rely on an imported engine, while the Mk2 aims to incorporate a domestically produced 120 kN power plant by 2038. That engine development alone represents a multi-billion-dollar technological hurdle involving materials science, turbine blade durability, and high-temperature metallurgy. Skepticism toward timelines reflects historical precedent. The Tejas light combat aircraft program illustrates the challenge. Conceived in the 1980s, the aircraft achieved its first flight in January 2001 after decades of work. The first squadron reached operational clearance in 2019, approximately 18 years after that initial flight. Costs climbed as well, reaching roughly $72 million per aircraft by 2025, partly due to reliance on imported US engines and Israeli avionics. In comparison, India's Su-30 MKI fleet, built under license from Russia, became the backbone of the Air Force with more than 270 aircraft acquired since 2002. The contrast extends to fifth-generation platforms. Russia's Su-57 has reportedly been procured domestically at significantly lower dollar-denominated costs when the ruble trades weak against the US currency, sometimes near $35 million per unit in those conditions. Meanwhile, China's J-20 production continues at scale, with estimates projecting up to 1,500 aircraft by 2035 if current output rates are sustained. Against that trajectory, any delay in AMCA deployment widens the quantitative and qualitative gap. Former Air Marshal Anil Chopra assessed in early 2025 that although the AMCA could reach a prototype stage within roughly 11 years from formal design, real-world constraints likely extend that horizon. By the time India inducts the aircraft, he indicated China may possess overwhelming numbers of J-20s. He further suggested that a contingent view inside India sees the need for an interim imported fifth-generation platform to narrow the capability gap, while noting that the US F-35 is considered politically and operationally restrictive due to Washington's controls over software, integration, and autonomy. That calculus has elevated the Su-57 as a potential bridge. In January, India was reported to be in advanced technical discussions to license produce at least 140 Su-57 fighters. Russia has offered extensive technology transfer, including access to source code, an unusual concession that would allow deeper customization of avionics and weapons integration. If implemented at scale, such a deal could mirror the Su-30 MKI arrangement, where local manufacturing gradually increased indigenous content over time. Recent operational comparisons have intensified the debate. The Rafale, India's most recent imported fighter acquisition, faced scrutiny after perceived underperformance in exercises relative to Pakistan's Chinese-supplied J-10C. While such comparisons are complex and often politicized, they reinforced perceptions of urgency inside segments of India's defense community regarding stealth and sensor parity. Two future scenarios now frame the strategic outlook. In the first, the AMCA program stabilizes. Engine development meets performance thresholds, stealth shaping achieves low observable standards, and flight testing proceeds within a compressed but manageable window. By the mid-2030s, India inducts its first domestically designed fifth-generation squadron. Over time, production ramps to meaningful scale. In this pathway, India reduces long-term import dependence, strengthens its aerospace supply chain, and positions itself as a peer competitor in advanced fighter development. In the second scenario, technical hurdles compound. Engine reliability lags, radar cross-section targets require redesign, and avionics integration faces software bottlenecks. Each delay shifts operational reliance further toward imported aircraft. India expands Su-57 procurement beyond the initial 140, potentially approaching 200 or more if the AMCA slips into the 2040s. The domestic program continues, but increasingly resembles a technology demonstrator rather than a near-term operational solution. Both trajectories carry geopolitical consequences. A robust indigenous AMCA enhances India's strategic autonomy and bargaining leverage with suppliers. It supports export ambitions and reinforces India's role in Indo-Pacific security frameworks. Conversely, large-scale Su-57 induction deepens defense industrial ties with Russia at a time when Moscow's own production capacity and geopolitical positioning are under scrutiny due to sanctions and shifting alliances. The regional balance with China remains central. China's aerospace sector benefits from centralized planning, vertically integrated supply chains, and sustained funding. India operates within a more fragmented procurement environment, balancing public sector entities, private industry participation, and parliamentary oversight. These structural differences influence development speed as much as engineering skill. Ultimately, the AMCA story is not only about stealth geometry or thrust output. It is about timelines, industrial ecosystems, and the trade-offs between sovereignty and speed. India must decide whether patience and domestic capacity building outweigh the immediate operational advantages of importing proven platforms.